morning, Calc fans. How we doing on this fine, sunny Monday morning? Yes, it is a Monday morning. Hope everything's going well with you and your family and your household. Hope you're keeping away from the illnesses. Hopefully you're keeping our social distancing there. Hope things are going well for you. Continue to keep up with the material in regards to the work that we have done. So just continue to keep up with the material. Today we're going to continue on with definite integrals. We have 4 more sections to do. We'll do 2 more this week. We'll deal with definite integrals, and we'll deal with another topic. Talk about areas in between functions a little bit more. But then we have some integration by substitution. But we only have 4 more sections that we have to cover here. So we'll cover 2 more this week, get a quiz. 2 more next week, get a quiz. Then we'll have a chapter test over chapter 5, and then we'll be done with this, with what we have here. So we have 2 quizzes, 1 chapter test, and then we have to prep for the final. Okay, so those are the things that we still have to be able to do. Hopefully we should be done here. This is last of April. Hopefully by the 2nd or 3rd week of May, we'll completely be done with calculus here. And then we'll be able to submit our grades to the University of Findlay. Once again, Findlay is still requiring us to be able to continue to go through the material, so you need to keep up with the material as best you can. If you have questions, if you have anything that you need from me, feel free to email me and I'll help you out as best as possible. On Friday, we talked about definite integrals, and just to review the idea of a definite integral, if we have limits of integration over an interval from A to B, okay, we can find what is called a definite integral. And we can find this by taking the antiderivative of our function and evaluate it from A to B, where capital F of x is the antiderivative of little f of x. And once again, we have our exponent rules that we can utilize, or the ideas that we've talked about before. Okay, then to calculate the value of this, we evaluate our antiderivative at b and subtract off the calculation of our antiderivative at a. Okay, so we determine what the antiderivative is. We evaluate from b to a, from a to b. So we do the top value first and subtract off the bottom value. And that's how we calculate our definite integrals. Well, today we're just going to deal with the average value of a function, and the average value of a function is utilized when you talk about the average temperature of a day. Okay, you can deal with a curve and an equation that will give you the temperature on a daily basis throughout the entire day. Just looking at the data points. What is the temperature on every hour, every half hour, or every 15 minutes, or every 10 minutes? Once again, decreasing our delta x, using our squeezing theorem, decreasing our values, we could come up with a function that would predict the temperature that it was throughout the entire day. Well, then you can calculate the average value of the function, which would be the average temperature for that day. Well, that's what we'll be dealing with today, is the average value of a function. And the average value of the function is just the antiderivative from b to a of the function dx, but then we have to multiply 1 by 1 minus b, or 1 over b minus a. We have a function f of x. We have an interval from a to b. This here is just the length of interval, which, if you remember talking about the average, we add up all of the values and divide by the total number of values. We take the antiderivative of over our entire interval and divide by the length of the interval. So that's the average value of a function. We have 1 over b minus a, the antiderivative from a to b of f of x dx. What we will be covering today is not very long. We won't be dealing with this a very long process here, but the average value of the function of x squared plus 1 over the interval from -3 to 3. We want to find the average value of this function. So we have the average value of the function is 1 over b minus a. Well, here's our a, here's our b. So we have 1 over 3 minus a -3. Watch your negatives there. The antiderivative from -3 to 3 of our function x squared plus 1 dx. So we can calculate the antiderivative from -3 to 3, the definite integral of this, and multiply by 1 over the length of the function. So we have 1 over 3 minus 3, which is 6. 3 minus the -3. We have to take our antiderivative of this using our exponent rule once again. ax to the nth power dx, the exponent rule is we add 1, so we have x to the n plus 1 power, and divide by our coefficient by this n plus 1. And this is what we need to evaluate if I'm going from C to D. Evaluate from C to D. So we take our antiderivative, we add 1 and divide by that, so we have 1/3 x cubed plus 1x. And we have to evaluate this from -3 to 3. So we come down to 1/6. We have to evaluate first at the value of 3. So we have 27 times 1/3, which is a value of 9, plus 3. That's my evaluation of my antiderivative at 3. 3 times 3, 3 cubed is 27, times 1/3 is 9, 1 times 3 is 3. And then subtract off the evaluation at -3. So we have to evaluate at -3. So we have -27. Once again, really have to watch our negatives here. -27 divided by 3, which is -9. Whoopsie. Minus 1 times 3, which is -3. So if we look here, we have 12 here, minus a -12. Which is 24. So the average value of this function is a value of 4. Assume a certain city, the temperature in Fahrenheit in T hours from 9 a.m. is represented by a function of this function here. We will use our calculator to be able to calculate this antiderivative. We want to find the average value of the function in the city during the period from 9 a.m. to 9 p.m. Well, the length of our interval is a value of 12. So what we have to really watch out for here is I can't take my antiderivative from 9 a.m. to 9 p.m. But I could say this is 0 hour and this is hour 12 at 9 p.m. So this would be our 0 hour and this would be our hour, 9 p.m. would be our hour 12. So the length of our interval would be 12 hours. So we have 1 over 12. We're going to evaluate our antiderivative from 0 to 12 of our function 50 plus 14 sine pi over 12 t. Now my variable I'm dealing with here is t, so I'm going to have to put in a dt. Now we can take the antiderivative of 50, and that would give me 50t, but being able to deal with this, we don't know how to quite deal with this yet. So what we're going to do is we're going to use our calculator to calculate this integral, because your calculator, once again, is very nice. This is a KYC moment for you right here. This is what we can use to be able to check our answers. So if we look at our calculator, the first thing we have to know is I'm taking the trig function here and a variable. Once again, as we talked about before in previous classes, degrees fall apart in upper level mathematics. So we need to make sure we're in a radian mode. So in my calculator, clear this out, I need to make sure I'm in my radian mode. So I go down to mode, make sure I'm in my radian mode, and then I'm going to quit. Now, what we're going to want to calculate is we're going to calculate, need to make sure my window is good. No, it's not. There we go. I need to make sure I cover my interval with my limits of integration. So I need to make sure my T max is above the value of 12, or my X max. And I'm good with the other values there. So if we go to calculate, if we look at option number 7, it gives us the antiderivative. It allows us to be able to calculate a definite integral. Well, I got a little funky function in there. So what I need to make sure of is I need to make sure I have the correct function. Well, I obviously don't have the correct function there. So I need to type in 50 plus 14 sine of, I'm going to attach the t with the pi. So I have x pi divided by 12. Need to make sure I close my parenthesis out there. I had to use the variable of x in there because I don't have a t variable here, so I need to make sure I have a variable I can deal with. That's the variable x. So if I go to now second and calculate the antiderivative here, the integral, first off I get my function. It doesn't look very big. Oh, I know why. Because if I look at this, if you think back to my world of graphing trig functions, this is your vertical phase shift. So I need to take my y value up to a value that I can deal with. My amplitude is a value of 14. So if you remember back, our prime axis would be at 50, and I would go 14 up and 14 down. So I need to adjust my y variable, my y window, so I can deal with this. So I'm going to go from, let's go 30 with my y minimum. This goes 70 with my y maximum. That would make sure if I'm at 50, I would go up and go down and be able to cover my graph. I'm going to scale this out at 5 so I'm not all cluttered up on my y-axis. Now if I look at my graph, now I have a nice little trig function there. Isn't that nice? Well, let's go to calculate. Once again, my integral, I'm going to go third trial. Let's go my antiderivative. Now what it's asking for a lower limit. Well, my lower limit is a value of 0. My upper limit is a value of 12. And what happens nicely is it sort of shades it in for you, which is good. Okay, if you remember back, the definition of an integral is the area between the x-axis and the graph of a function. Well, here's the graph of my function. Here is my x-axis down here. The area shaded is 706.95. So we have 706.95, and we have to multiply this by 1/12. So we're going to have to divide that by 12. So if I take the 706.95 divided by 12, I get 58.9 degrees. And that would be the average temperature from 9 a.m. to 9 p.m. From 9 a.m. to 9 p.m. on a particular day. One value, which would be the average temperature. Okay, which is a lot easier than going out and reading the thermometer every 10 minutes or 5 minutes and getting a temperature, and then calculating all your data values and determining what the average is. So this is another way of being able to utilize, once again, a little KYC, know your calculator, what your calculator will do for you. Now, when dealing with definite integrals, you can go ahead and utilize this to check your answers. I don't want you to utilize it to be able to find values. I want you to be able to utilize this to be able to check your answers. One last problem I'll go through very quickly. Suppose we had, let's see, 2 square root of x dx, and I want to evaluate this from 4 to 9. I want to be able to calculate this. Well, what we need to be able to do is we need to be able to deal with the exponent rule here. So we have 4 to 9, 2x to the 1/2 power dx. Now if I first evaluate my antiderivative, I need to take my antiderivative here. So we need to add 1. We need to add 1. So we have x to the 3/2 power, and take our 2/3, or 2, and what I'm going to do, I'm going to make this 6 instead. I'm going to make that 6. Sorry about that. So we need to take our 6 and divide it by 2/3. I'm sorry, 3/2. Well, we have 6, and we have to divide by 3/2. Well, if I have 6 divided by 3/2, this is 6 times 2/3, which gives me a value. This would cancel 1 and 2. 2 times 2, which is a value of 4. So we're left with 4. Now this x to the 3/2 we can write as x square root of x. We need to evaluate from 4 to 9. I changed this to 6 so it cancels nicely for us. So evaluating this, we need to first evaluate at a value of 9. So we have 4 times 9 times square root of 9. Minus the evaluation at the value of 4. So we have 4 times the square root of 4. So we have 4 times 9 times 3. So we have 36 times 3 minus 16 times 2. Let's see, 36 times 3 gives me 108 minus 32. So we have 276 squares. So once again, we can deal with all types of functions here. We just have to once again get it into a form that we can deal with. This will help you also on one of the problems that you had on your worksheet. I posted a worksheet also for you to give you additional practices. Please do continue to keep up with the material that we're going through here. We are almost done. You have done a nice job up till now. You've done a nice job. Continue to keep up with the work. We'll be through this quickly. Once again, my goal is to finish out by hopefully the second, maybe take the final the third week of May. Give us a week, or give us 2 or 3 days of preparing for the final, and then having the final the third week of May, and then we'll be done with this class. So please do keep up with the material. You've done a nice job up to now. I miss you guys. I wish you were still sitting in a classroom, but you've shown me, and you've shown yourself also, that you have a growth mindset in regards to being able to learn in a different way. Okay, you've been able to do a different way, in a different manner of learning, and you've done a nice job. Keep up the good work. Once again, we'll get back to some sort of normalcy here eventually, but just keep up the good work. It's what our reality is right now, and that's how life is. We just work with our reality at this point. So I have nothing else for you. Continue to work, continue to do a nice job. Adios, we'll see you